All right. So for today's session, what we're going to be focusing in on today is Boolean logic and comparisons. From yesterday's session, we spent a lot of time talking about the different data types. And the last data type that we have not talked about just yet are Boolean data types. So this is what we're going to be diving into today. We're going to see some of the more interesting aspects of Jinja and how it relates to this data type known as Boolean logic. So let's go ahead and dive in. So first and foremost, we're going to step back in time and talk a little bit about where Boolean logic comes from. Way back in the day, when computers were being built, they were built using these things called logic gates. These little, little chips that you put on circuit boards, and it takes electrical inputs and then outputs an electrical signal based off of the way that it was designed. And these were the building blocks of modern computers today. Processors, RAM, everything in between was built using these things called logic gates. And so we talk about that because we've lifted a couple of these logic gates and specifically the way that it functions, and we apply those today programmatically. And the way that it is expressed is with the output. When we talk about Boolean as a data type, the value that we expect to see from Boolean data types is either true or false. It either is or is not. It's either a 1 on or 0 off. That's effectively what Boolean values are. It's just true or false in the world of Jinja. And we've seen these in action before. We saw how when we created a custom condition within our transitions, if the custom transition is true, then the transition follows to what's connected to. If it's false, we leave it alone. So we've seen that already with the comparison of the add to the action variable, comparing what's on the right of the two equal signs to what's on the left of the equal signs. And if they are indeed equal to each other, that renders a true, and then we follow the transition. We've also seen an example of other keywords that helps us decipher some of these things as well. Words like or as well as not. And so these are known as operators, and these are things that we did not explicitly talk about back over in our previous courses that we're going to spend some time talking about now. So these operators function based off of these three key words, inspired and lifted from the era of logic gates. So those keywords are and, or, and, as well as not. And so the way that the keyword and works is very similar in English, right? If I say a statement such as, Eddie and Brandon are conducting their training, in order for that English statement to be true, both Eddie and Brandon need to be present to conduct the training. And in the Boolean operator world, that's also the same. When you have the keyword and, both sides of the left and the right of and need to be true. So if it's in the sense of, is the user logged in and in admin, both of those instances need to be true in order for and to say the whole thing is true. So and both sides need to be true. Or is either one, the other, or both. So if I said Eddie or Brandon will be conducting the training today, it could be Eddie, it could be Brandon, and it could be both, right? So that's the idea of or. One, the other, or both. And then not is just flipping values. So if I said Brandon is not conducting the training today, right? Just like in English, right? He's not here, he's not conducting the training. That statement is true, both in the Jinja perspective as well as in the regular English. So a couple of examples here, right? We're comparing to the left and to the right of these keywords and or not. So true and false is going to give us false, since both sides need to be true. True or false will give us true. False or true will give us true. True and true will give us true. And then false or false will give us false. And then again, not is just flipping values. So you go from not false, and it's going to give us true, like we see here. So those are the operators, those three keywords. And then from here, we can also compare things, whether comparing numerical values or just comparing the values themselves. So when we compare numerical values, this is just like in regular math using greater than and less than symbols. To do greater than or equal to, we just put an equal sign at the end. So greater than or equal to, less than or equal to. The one that we were already introduced to is these two equal signs, right? Two equal signs lets us know we are comparing what's to the left of the two equal signs and what's to the right of those two equal signs. And then not equal to is just that. Is the thing to the left of the equal sign not equal to the thing that's on the right? And then some examples here to highlight how those functionality works. So pretty straightforward for the most part in regards to how we're able to do these comparisons, how we're able to use these operators. Now, the quirky part when it comes to Jinja is this idea of truthy and falsy. We talked about how the Boolean data type is in reference to data that's either true or false, right? It's only going to give us two values. But what truthy and falsy allows us to do is to interpret all of our other data types and either see whether that other data type is true or false. So you can force or you can get something like a string to render true or an empty list to render false, even though those are not technically Boolean data types. So the idea here in general is that if our data type contains something, it's generally going to render true. That's what makes it truthy. So a string or a list with something in it, when you evaluate it using Boolean operators, you can get a true value out of it. And similarly for falsy, if it's empty, like an empty list or an empty string or the number 0, those can be evaluated as false. Again, despite them not technically being a Boolean value or a Boolean data type. So again, a couple of different examples here. The true will always be true, false will always be false. And just following the general guideline, if there's something in there that's an actual value, then it's generally going to render as a truthy value. And then falsy are things that are representing emptiness, empty string, empty list, the number 0, things like that. Now, what this allows us to do is it allows us to write our Jinja either implicitly or explicitly. And there's a lot of different situations that can take advantage of this. So a very, very common thing that we often check for is to see if a list is empty or not. And so many people, including myself, will write Jinja in an explicit manner to check to see if the list is empty or not. And the way we generally do it is, hey, let's grab our list, let's send it to the length filter, and if it's greater than 0, that means there's something inside of it. So an explicit conversion to see if the list is empty or not. But if we utilize this idea of truthy and falsy, you can just say if and then the list. And because of this idea of truthy or falsy, Jinja is intelligent enough to see, hey, if there's anything there, I'm going to throw a true. And if there's nothing there, I'm going to throw a false. So we can either go explicit or implicit when we write our Jinja. This is, again, especially useful if we're checking to see if something is there or not. So how does that relate to creating clean code? Well, there's a lot to talk about here, so let's just dive in. There are instances where you might write Jinja that looks like this, and at the time when we write it, it makes sense, right? We usually, you know, take our thoughts, put it down on paper, and then we kind of go from there. Sometimes the issue, though, is when we come back to it or someone else is reading our code, it could be something that's difficult to grasp or to comprehend right away, right? It might require us to read again and again and again. And so with this idea of clean code, we are again circling back with this idea of tech debt and finally filling in the last area where we encounter tech debt is within our code. When we write clean code, right, adhering to a lot of the principles that we talked about, this creates the situation where we're not spending so much time figuring out what the code does or introducing new errors into our code because we might have been over zealous, over verbose, or writing too much or too little within our code. And so clean code ultimately is here so that we maximize the value of our automations. So let's talk a little bit about some strategies that we can apply to help us write cleaner, more readable, more simple code. The first one here is grouping logic, right? So how can we group together things that should be grouped together to either help us with readability, maintainability, or something in between? So there's going to be 3 tools at our disposal to help us out with this. We're going to have the parentheses, we're going to have the brackets, and then we're going to have white spaces and line breaks. So let's first talk about the parentheses. When we're using parentheses in Boolean logic like so, there's 2 reasons to do so. The first reason, and what we're highlighting here, is that it helps us better visualize the priority of what's being executed. So in this example here, by putting the parentheses around user is admin and user is active, we are highlighting visually that this is what's going to be executed first. Now, what we're going to see in the example is the parentheses also follow the algebraic order of operations. So the PEMDAS, right? Please excuse my dear Aunt Sally. So recalling from algebra, we know that whatever we put in parentheses in algebra is what we work on first. And that's also true here within Jinja. So if I put my parentheses around user is active or user is super admin, my parentheses are there, then that is what's executed first. And that can also affect the way that our logic works. So something to keep in mind when we use parentheses. It is used to help better visualize the execution order or to control the execution order, right? Depending on what we want to do. The next thing to help us with writing a little bit cleaner code is in regards to grouping. When we are checking one attribute for multiple values, the temptation could be to use this keyword or. You can say this or this or this or this or this or this, right? Checking for all the values that this one attribute could contain. What we can do instead is use this pattern here. We utilize the keyword in, and we check to see if any of the values that we want to check for is in this value or in this variable here. So a very nifty way to help us kind of consolidate the amount of code that we need to write if we're checking for multiple values for a single attribute, property, key, etc. So that's grouping with the square bracket. And then finally, the last thing here is white spaces. When it comes to white spaces, as long as we have that dash in Jinja, at the before and the after the 2 curly brackets or the opening, closing percent signs, Jinja doesn't really care about the white spaces so long as we use the dashes. With that, we can format things kind of however we want. You can use tabs, spaces, indentation, line breaks, etc., to try to better group together logic. Right? So a lot of this is subjective. A lot of this is stylistic preferences. And so at a high level, we encourage you to take advantage of using line breaks, tabs, spaces, etc., to better help you visualize your code or the people in your organization. Right? There's no tried or true way per se. Again, different people like to do it in different ways. All right, next up here, we're looking at how can we simplify some of our Boolean logic. Right? So how can we make it simpler? And we're going to be focusing in on two different methodologies to help us out with this. The first one is implicit conversions, and the second one is ternary operators. Let's first talk about the implicit conversions. Now, again, circling back, implicit conversions are possible because we have this idea of truthy and falsy, where you can get Boolean outputs or Boolean values out of data types that aren't technically Boolean. And so with this helps us create implicit conversions to check for specific things, whether they're empty or they contain something. And with that, this allows us to reduce the amount of text, the amount of code that we need to write when we are checking for those, again, specific things. So instead of checking for an empty string or checking for an empty list, you can just check the string or check the list itself. And Jinja with the truthy falsy will give you a true if there's anything there, or give you a false if there's nothing there. And this also works for like weird edge cases, like if something is null, for example. But you can just kind of see in some of these longer examples, right, when you're doing conversions of is this true or is this not none, you can just kind of reduce it down to make the code a little bit cleaner. Now, before pushing on, if I just take my Rewst hat off really, really quick, there is, to a degree, a lot of thought behind this, right? There's a lot that we can say. There's a lot of nuance behind this conversation. Now, again, with my Rewst hat on really, really quickly, we recommend writing implicit conversions, right? Because when you look at this, it does make our code look cleaner. There's less stuff, right? You don't have to read as much or be confused by a lot of things like is not none, for example. The one hiccup here is sort of the ramp up time, right? We can use implicit conversions here because all of us here in this conversation are coming to the understanding that there's this idea of truthy and falsy. This is something that's unique to Jinja here, or unique to Jinja. It could exist in other programming languages, but it's not something that's very typical. You don't oftentimes see people writing implicit code in this manner. And so with that, if people are not aware of this truthy falsy and they look at our code, it could be a little more confusing, right? Because of that, again, technical knowledge that isn't there. So I do caveat that by saying, yes, when we write explicit conversions like this, it's very natural, right? It's very easy to figure out what's happening because the conversion is explicit, right? If we keep it short like this, being explicit to a degree is all right, right? The functionality is the same, and it has this sort of additional layer of, by being explicit and understanding code, right, pretty straightforward in what's going on versus the implicit. But at the same time, just like as we compare programming languages to real life languages, there is times where we are more, we use more words to explain something when there are opportunities to just use a single word, right? Sometimes it's lack of vocabulary, sometimes it's lack of understanding, and sometimes we need to be more explicit using simpler language in order to convey a thought or a point. But once we have that understanding and we know what a single word means, you can use that single word to express a bigger concept. So there's a lot to say here about implicit, explicit conversions. Again, in personal preferences, I do write implicit conversions. I prefer explicit conversions. Most people who write code within Rewst who have this understanding of truthy and falsy will also do it as well. That's not to say you can't use explicit conversions. It's something you can, but it is something to consider when thinking about this implicit, explicit as it relates to writing cleaner code, right? Who is it that you're writing the code for? Who is going to be reading your code? Who is going to be maintaining your code, your workflows, etc. Right? And if it's you, right, then write it with you in mind. If it's you and your coworkers, right, guys get together and kind of figure out, hey, what's the approach that you guys want to take? Because ultimately, this is for you, right, and for your team if it's going to involve your team. So do the thing that best serves you and your team. And again, our general recommendation is go the implicit conversion route, since now you understand truthy and falsy, kind of know what it does, how it works, can help simplify the amount of code that you actually need to write. So speaking of writing code, the second way to help us with writing cleaner code is ternary operators. Ternary operators is just a very specific syntax that helps us assign values if a specific condition is either true or a condition is false. So you might say, if this condition is true, I'm going to set the value of this variable to this. Or if it's not true, I'm going to set the value to that. Right, that's a lot of code to write with all of the percentage signs and the if else and the if and all of that. So ternary operators is just a way to help us simplify the way we write these if else statements. And so looking at some examples here, it actually kind of reads very, very naturally. So again, we're creating a variable using the keyword set in the first example. We have a variable known as status. And the value of status is active if user.isActive is going to be true. So using the implicit conversion here. If I get a true value, then the value of status is active. Otherwise, or else, the value will be inactive. So set status equal to active if user is active, else inactive. Over here, we're going to be outputting something with the two curly brackets. So in this example, we're going to output welcome back if user.lastLogin is true. Otherwise, or else, we're going to output first time login. And then last example here, we're going to have a variable called greeting, and the value of greeting will be equal to good morning if the time is less than 12. If it is less, or if it isn't less than 12, we're going to have it be good afternoon if the time is less than 18, which is 6 p.m. Else, the value will be good evening. So seeing how we can kind of cascade this down and check for multiple conditions, very similar to the else if paradigm. And the last thing here is more of an optimization. And the optimization is known as short circuit evaluation. This is especially useful in our workflows. And again, it's just an optimization. What short circuit evaluation allows us to do is if we're checking for multiple conditions and there's only one specific condition we're looking for, then we want to put the condition that we're looking for as close to the first thing as possible. Or in other words, let's say, for example, you're checking for 3 different conditions. One condition occurs 80% of the time, another occurs 15%, and then the other occurs 5%. So if there's only one condition we're looking for, and there's one that occurs 85% of the time, then it stands to reason that we should check for that condition first, since it's the most likely one to be checked. And if the logic says, if you check this condition and it's true, and we go do something, then we can disregard everything else. So it saves us that little bit of processing power to check the other things. Whereas if you did the reverse and you checked the least likely outcome to occur first, then you have to check that and then check the other ones and then check the other ones. So that's the idea of short circuit evaluation, right? You want to evaluate the thing that's going to occur most likely first, and then with that, you can try to skip everything else. So that's the idea here. All right, so let's see some of these things in action. And again, if you have any questions at any point, always feel free to type it out in the chat. So there's a link here. You can go ahead and click on that link, and it'll bring you over to your instance of Rewst, and it'll bring you over to the Jinja Live editor. All right, so let me jump over there. I'll move teams, and we'll make sure that we got everything working the way that it is supposed to be working. All right, so let's go ahead. We'll start sharing screen. All right. So here in the Jinja Live editor, after clicking that link, it's just a couple of examples here just to kind of highlight and see the things that we saw in the slides, just to kind of seeing is believing sort of thing. So again, keyboard shortcuts, Command or Control / toggles the comment, so you can turn it on and off. And then to run the code, it's Control Enter like this. So we're checking to see if the user name is not empty. So this is an explicit conversion. But if I go over here and go the implicit conversion like this, then it still renders true, right? Confirming that this has some sort of value in it. If I get rid of the value here, so that username, so that this is empty, let's see if I can see. Will that still run for me? I don't think it will. It still sees something there. Let's try that. Yeah, so empty string here, right? There's no value, right? So we get a false, nothing comes out. So I'll call them John Doe. So just kind of confirming that. Right, same thing, right? Very common example here, the checking to see if there's anything in a list. So our list is over here, it's called lists, and then this user underscore list down here, right? Checking to see if the length is greater than 0. So it's going to be 2, so we see list is not empty, right? But again, if I just get rid of this stuff here and run it again, the outcome is the same. Just to make sure list is still not empty. Right, so nothing caching. This is exactly as we expected. So implicit conversion here, checking to see, hey, is there anything in our list? Now this example here, this is doing explicit conversion to see if is active is equal to true, and if that user subscription is not none. So making sure there's actually something here in this subscriptions list. So when we run it, there should be something there. User is active and subscribed. And we can do the implicit conversion and get rid of those checks like this. So just get the values. Is active, true. In this case, they are. And user subscription, it has stuff in there. So this will also be true. So something like this. And then I'll put the text here just to, again, confirm nothing indeed is being cached. All right, let's take a look at some other things. So next, we're going to look at grouping to see if we can better group this chunk of code here. So we see if ctx user is admin and ctx.user is active, or ctx.user is super admin. And so this is just going to read from left to right. So the and, these two things here, this guy and let's see if I can get it highlighted correctly. All right, close enough. Right, the is active and is admin are the two things that are going to be evaluated with the and whatever outcome comes from the and will then be compared with the or. So if I go like this, the functionality is not changed. It's just emphasizing what's happening here. So is the user an admin? No. Are they active? Yes. Are they a super admin? Yes. Okay. So this and here is going to give us a false. And then the or right here is admin. We said that's true. So regardless of what happens here in the parentheses, since we have a true here, with the or, this will render true. So one side is true, the other side is true, or both sides is true with the or. Now, if I move the parentheses though, and I put the parentheses over here, this is going to change the functionality because now we have put this in parentheses, and because of that, it will evaluate first. Since what's in the parentheses is going to evaluate first, we'll see, is the user active? Yes. They're super admin, true, since both sides is true. With the or, still true. But now that we have the and, we now compare, is the user an admin? And what's in the parentheses, is that true as well? In this case, what's in the parentheses is true, but because the admin is false right here, this is going to come out as false. And so nothing renders out. So we can see here that the functionality has indeed changed based off of how I did the parentheses. So if we do use parentheses, be very mindful of that. Whatever's in parentheses will execute first, following order of operations. All right, next example here is using that keyword in and then the square brackets. So over here, we see that we are checking to see if this attribute, user.role, is equal to admin or if it's equal to super admin. So we can simplify this. So the attribute itself, ctx.user.role, we're going to check to see in and then the list of values that we're checking for. So admin and then super admin like this. So something like this. From here, we can then kind of make things a little different here. So kind of jumping ahead, one of the advantages of this is that it makes it easier to add more values. So just a comma, this is like another value, right? Comma, another value, things like that, right? Or if you want to break it up so that it's its own line, you can do that too. Right? Again, stylistic, whatever methodology you want to take, it does make it a little bit easier to change regardless of if we do the white spaces or not. All right. And then last example here, the ternary operator. So a couple of things, again, just kind of seeing it since it's something that is pretty straightforward. So this guy here, let's see if I can get the comments out. Let's see. Oh, it's just a single one. That's my fault. So there we go. So just kind of seeing it in action. So again, the structure here is the value you want if the thing we're checking for is true, else the value when it's the thing that we're checking for is false. And then you can nest these as many times as you'd like. All right. And with that, that does bring us to the end of Rewst 204. As always, I want to thank you guys for learning Rewst with me. In this case, learning Jinja with me.